All right. So at the top of the page, as part of the warm-up, I asked you to find the additive inverse. If you go back and you think about the word additive inverse means what number can you add to that and get 0. So additive inverse is a fancy way of saying the opposite. So what is the opposite of each of those 4 values? So the opposite of 4, negative 4. Opposite of 2y, negative 2y. If the value you get is a negative to start, then opposite of negative x is positive x. So today we're going to algebraically learn how to solve systems using the substitution method. So the substitution method is exactly what you think. If I ask you to substitute something, you are taking it and replacing it, right? So if I were to be absent from school today, a sub comes in to replace me, and then I come back tomorrow. So a substitution method in math is where you take something and you substitute it with something else. So in that warm-up, what we're going to do is replace x with 2y minus 1. We're going to substitute it in. So everywhere you have an x, I want you to replace it with 2y minus 1. So everywhere you have an x, replace it with 2y minus 1. So we get 2y minus 1 plus 2y equals 3. Now you're going to combine like terms. 2y plus 2y is 4y. Minus 1 equals 3. You want to get the numbers on the right. So we're going to take negative 1, add it to the other side. So you get 4y equals 4. How do you get y by itself? You divide by 4. 4 divided by 4 is 1. So you get y equals 1. Same thing in number 6. Everywhere you have an x, replace it with 2y minus 1. What happens in number 6 is you have to be a little bit more careful because there's a negative 2 being multiplied out. So you get y minus 2, 2y minus 1 now instead of x equals 8. But that negative 2 is going to go both to the y and the negative 1. So you have to distribute the negative 2. So you get y minus 4y plus 2 equals 8. Combine like terms. Solve for y. And your y equals negative 2. And then the last one. Everywhere you have an x, 2y minus 1. Distribute your 3. Combine like terms. Divide. And want to simplify. Root negative 2/8, totally fine. Root negative 1/4, totally fine. If you did it on your calculator and you got negative 0.25, totally fine. So again, 3 ways, 1 solution. That is kind of the basic foundation for what we're going to do today. The only thing we're going to do is add 1 step to it. What if all of these answers have? They're all y equals. What are you missing that is part of your answers? You're missing the x equals. So what we're going to add is the x equals. So the steps to solving by substitution are pretty easy and pretty similar to what we just did. Solve one of the equations for one of the variables. It does not matter which one. Substitute that in. That's what we did. The substituting in that problem was replacing every x with 2y minus 1. That was the substituting step. Solving was getting it down to that answer. Now, so like the new steps are 1 and 4. 1 is that you have to pick the variable you're solving for instead of being told. And 4 is to find the other value. So 2 and 3 are what we just did. We're adding 1 and 4. And that will be good. When looking at solving by substitution problems, what you want to do is look for the variable that has a coefficient of 1. So what I mean by that is the number in front of the variable. So which of those variables has a coefficient of 1? Y. So we are going to pick this y to solve for, because it's going to keep you from having fractions. So you want to look for the one that has no number on it. So solve the bottom equation for y. Now you're going to do exactly what we did in the previous warm-up. You're going to take 7 minus 2x and replace y in the other equation, not in the one you solved for, in the other equation. So this is going to become 5x minus 3 equals 23, but now instead of y, we're going to replace it with 7 minus 2x. So now, my entire problem is in terms of x. So I can solve for x and get an answer. Remember, a negative times a negative is a positive. So 5 plus 6 is 11. Add 21 to the other side. Divide by 11. This is where the new step comes into play. We can't just stop at x equals. We need to also know what y equals. So we're going to take that x and substitute it back in. So you can plug it in for x here. You can plug it in for x here. You can plug it in for x here. It doesn't matter. All three will get you the same y value as long as you know how to mental math, right? And then let's multiply around. So y equals 7 minus 2 times 4 which is 7 minus 8. 7 minus 8 means that y equals -1. Remember yesterday when two graphs crossed and you wrote down the intersection and it was a number? Not going to be on the screen. This is that point of intersection. If I were to graph these on a graph, they would hit each other at 4, -1. So if I were to graph them, that's right, I'm here. They would hit each other at 4, -1. Oh, do you know it's out of 20 again? I'll take my 10%. Figure out what to do. All right, guess what? Number 2. Does it matter what equation I solve for in number 2? No, because like x and y both have coefficients of 1. So pick one. It doesn't matter. I could say, hey, left half the room do x. Hey, right half the room do y. Yeah, our math isn't going to perfectly match figuring out because at the end would. Since we solve for y there, let's solve for x. So you subtract y to the other side, you get x equals -12 minus y. Take that and substitute it in up here. So again, if you solve for x, you replace x. If you solve for y, you replace y. And you always replace it in the other equation. So distribute, combine like terms, solve for y. So I'm going to move my 24. I'm going to divide by -5. And solve for y. So I get y equals -6. I have to take that answer, plug it back in to solve for x. A minus is a positive, so you get -12 plus 6. So I get x equals -6 also. So, and again, that should make sense. -6 plus -6 is -12. In number 3, there's only one really, truly smart answer to solve for. What do I want to solve for in number 3? Y. And I want to solve for it by moving the y this time, not the x, because it's negative. So if you add it to the other side, it becomes positive. So you get 3x equals y. This one's the nicest of them all because you don't distribute anything. There's no numerical aspect. So take 3x, plug it in for y. Multiply. Combine like terms. Divide. And solve. So again, solve for a variable, substitute the variable, solve for that variable, substitute it, and solve for the original variable. It's very methodical. So it's like a memorizing type of math problem. If we haven't had those in a while in here, everything's been like, well, sometimes it's this way, sometimes it's that way, sometimes it's this way. So everybody likes substitution because it makes sense. It's like you do this and then you do that and then you do this again. Boom, 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 boom. There are very few cases that are unique. We're going to talk more about those tomorrow. The only thing that kind of really happens is these are really, really good word problems. Like Keystone word problems, SAT word problems. So we have word problems in here. These are the types of equations that really lend themselves to being a word problem. So it says that you go to a pizza store and they have 2 deals for the day. The first deal is a soda with 2 pieces of pizza costs $10.25. The second deal of the day is that 4 pieces of pizza and a soda costs $18.75. This better be some massive pieces of pizza. So we want to find the cost of the soda and find the cost of a single slice of pizza. So in order to do that, we need variables and equations. So in here, it's always safe to make your variables x and y. It's just safer. You're not going to make, like if you pick t, then sometimes it looks like a plus sign. If you pick s, sometimes it looks like a 5. And I've seen people make mistakes because they pick bad variables. So x is going to be soda. Y is going to be pizza. Write your equations. So a soda means how many? 1. So 1x plus 2 slices of pizza of y equals $10.25. The second deal is a soda, so 1 plus 4 pieces of pizza is $18.75. Both equations have coefficients with 1 on x. So you pick one. It doesn't matter. Pick the top one or pick the bottom one to solve for the problem. So let's just say x is 1025 minus 2y. So I'm going to replace this x with that x. Combine like terms. So I get 2y is 850. So divide by 2. And I get a single piece of pizza is $4.25. What am I missing? I am missing the cost of a soda. So we're going to take that 4.25, plug it back in. So x plus 2 times 4.25 equals 10.25. 2 times 4.25 is 850. 10.25 minus 850. If I'm running out of room to write it down, is $1.75. I would totally write more steps on the normal problem, but space was limited. 0 space. Are we okay with that? Next problem, which every time I read this one I go, man, I really need to change it, because there's going to come a day where students are like, what's this easy? You guys don't have to, like, Don't buy CDs like we used to buy CDs. iTunes and Spotify and all that other stuff. So, 10, 15 years CDs. So you can buy CDs at a local store for $15.49. You can buy them online for $13.99. But we know that if we buy something online, we have to pay to ship it. So find the number of CDs that you could buy that would be the same if you went in person or online. So we'll say Y is the cost and X is number of CDs. So online, my cost is $13.99. In store, my cost is $15.99. X is the number of CDs I'm going to buy at that particular price. But if I buy them online, I have to pay to ship them to me. Do I pay shipping per item or per box? Per box. So that's just an extra added $6 fee. So if I want to know when online and in store cost the same, we're going to set them equal. So right now, both are set up with y equal. So this is still a substitution problem in the sense that you are going to substitute this y with that equation. We're just going to go replace it. So 15.49x equals 13.99x plus 6. Subtract $13.99 away. So $1.50x equals 6. Divide both sides by $1.50. So it says find the number of CDs that you can buy. So if I buy 4 CDs, my cost is the same regardless of where I buy it from. If I buy 4 CDs, it doesn't ask you how much it costs, right? Don't do extra work. You don't have to type Y in this case. It doesn't ask you how much it costs, it asks you how many. So make sure you know what you're being asked and know how to answer it. Everyone's like, I hate word problems. Okay, your homework is the front and the back of that next page. I think I only gave you one word problem. Yeah. So that's not bad. These attempt the word problem.